Everybody's Tyler here at Score Signature Event, checking in 550G Goofy Goobers. I'm here with Reef to talk more about this awesome robot. We just watched it compete on the field. A lot of great stuff going into it. It's one of the fastest intakes that I've seen here in high stakes, so we can't wait to talk more about what goes into all of this, but just a very well constructed robot as well too. So we'll be diving straight through that journey, that ring journey as it goes through the robot, learning more about some of the changes they made, and a lot more coming up here on Bits and Parts.
This video on fun is brought to you by viewers like you and also in partnership with the following. The Robotics Education and Competition Foundation provides fantastic programs for students from elementary school all the way through college. These include VEX, aerial drone competition, online challenges, JROTC, Girl Powered, scholarships, certifications, and so much more. To discover these exciting opportunities, visit recf.org and get connected.
Reef, let's talk about this wicked fast intake that you have on your robot. Walk me through that, and we're going to be doing just a great overview of this machine.
All right, so the best thing about our intake we found that's worked the best is the second stage on the first stage here. We find that it gives the ring the extra push to meet with the second stage, allowing for the intake flow to be precise as possible. We run our first stage here at 300. It's chained throughout. It's a 24 to 16 using the mini chain. That allows us to more lightweight, and also mini chain tends to break less. Bringing it up through, we run our second stage at 600, which we find gives it that perfect flow from the first stage to the second stage, as 600 might jam the first stage a lot rather than the 600, with the 300's a little slower, but it allows for the continuous flow of the intake.
Yeah, see a ring go through it. Take a look at that. Very fast, very efficient process you have in there. When did this robot iteration come together? Like, when was kind of your last rebuild?
So this is our 7th rebuild this year.
Wow.
We found, because we just like to do a Mogo bot, because we find that early season Mogo bots were key of like the third goal would win matches rather than wall stakes. Well, now with matches getting more competitive and more teams becoming better and having consistent wall stakes, we found that we needed a wall stake. So this robot was built about 4 weeks ago. It was our last at our home comp, Apopka, we used this bot. And at an away comp at Timber Creek High School, we use this bot. We ranked 3rd with this bot at Timber Creek, and we ranked 2nd at Apopka with this bot. So it's been very good for us.
Your team has also won 2 Excellence Awards this year as well too. Can you just break down a little bit, like what is attributed to your team being so successful on that front also?
So we have really great team organization. My 2 notebookers, Karina and Emily, they give us Gantt charts and they keep us on track. So we have a class for this. So it's our 7th period. And at the beginning of a class, we actually have a 5-minute breakdown of what we're gonna do today and how we're gonna get it done. And then our notebookers keep us on track, gives my coder time to code, gives me time to practice driving, and our builder time to build.
Very cool. What are some other attributes of this robot you want to talk about?
Another attribute on our robot is our omnidirectional clamp here. It allows us to grab a goal from any side. At any angle. So we can grab it from the flat side, grab it from the corner, and we can grab it from this angle right here. And it just allows us to be as efficient at scoring as possible, as we don't have to worry about just grabbing the flat side of the goal.
How has some of your math strategy changed coming into the score? You know, we've had the recent updates with the 30-second rule. This obviously signature event competition is very difficult, but your team's been doing really well so far. So how have you approached some of that strategy?
The biggest thing for us, especially with score being a signature event, AWP is a lot harder to get. Yeah. We found that AWP actually helps you rank higher than necessarily winning auto. So we actually configured a solo AWP code for signature events, so we can get solo AWP by ourselves as long as our teammate drives offline. That helps us rank higher. And we also like to go for wall stakes early now to cancel out the other team's wall. If say they get top ring on the other stake, if we have 4 on ours, it cancels out their top ring, and we get the extra 3-point advantage.
Looking at events, past score here as well, what other major changes would you maybe look at making on your robot?
Are you talking about for like future comps?
Yeah.
For Worlds, we're looking at doing a tier 3 Lady Brown. Originally, we actually had a tier 3 design that we found it was inconsistent, but worked. Not necessarily perfectly, but it worked. And we're gonna try and incorporate into this Lady Brown robot with a PTO to the drivetrain.
Talk to me about your wall stick mech currently right now.
So currently our wall stick mech, it's we run it off a 5.5 watt to give us the split intake. It's run a 12 to 48 tooth gear, which runs our dunker at 50 RPMs. which is, it's a little slower than most traditional dunkers that are run at 66 RPMs, but we find that it's not noticeably different to cause an issue. So when we run our intake, we run our dunker off a state machine using the rotational sensor. So it just sets it to a primed position to allow for the intake of rings, and then it sets it to a dunked position whenever we need to dunk. We found that the state machines work very well as the rotational sensor gets it to the exact value. With some slight issues with the Lady Brown though, we find that since it's a lot shorter than a traditional dunker, we have to have the ring sit in the dunker as it was a 25 long dunker. So with us using a 180, it needs to be shorter to fit within that 24-inch limit. So our ring sits, it comes in and it tilts. When it sits in it, it's tilted. So that allows us, when we pull the ring up, it hits this backside, flipping the top of the ring over, scoring it onto wall stakes.
Overall, this is a very well-built machine, so congrats to your entire team for making this so far. I got to ask you last thing, can you tell us a little about your mascot as well?
What was that?
Can you tell us a little bit more about your mascot?
So this is Deanitor. He's been to every comp this year, and he's basically our good luck charm. He has the Krusty Krab hat to go along with the Goofy Goobers because it's SpongeBob related, and yeah.
Excellent. Well, Goofy Goobers, thank you so much for taking time. We really appreciate it.
Thank you.
Good luck here at this competition. A lot of great things that teams can take from this and break down a bit more, so we can't wait to see how you do here at Sport. Thanks a lot.
The Robotics Education and Competition Foundation provides fantastic programs for students from elementary school all the way through college. These include VEX, aerial drone competition, online challenges, JROTC, girl-powered, scholarships, certifications, and so much more. To discover these exciting opportunities, visit recf.org and get connected.